everyone, it's Amelia again. I'm doing another live video. Thanks very much for joining me if you're watching this now. It's that time of year where Year 11s are starting to go, wow, chemistry just got really hard because they've started to cover the mole theory. The mole theory, let me preface this with the fact that yes, this is hard to get your head around. If you're struggling with the mole theory, know that you're not alone, and it's something that you can get your head around. You just need to spend a bit of time with it. So let me give you my perspective on what the mole theory is and how it works. So I liken the mole theory to eggs. So imagine that, think about eggs that you buy at the supermarket. Essentially, imagine that you can only buy eggs in dozens. Forget about the fact that you can buy half dozens, and forget that you can buy the trays of, I don't know how many are in the trays, 48 or something. Imagine that you can only get them in trays of 12. Okay, so we call a tray of 12 eggs 1 dozen. Okay, in the same way, we call 6.02 times 10 to the 23, so that's a really big number, right? We call that 1 mole. Now, if you don't know how big 6.02 times 10 to the 23 is, it's 602 with 21 zeros after it. It's a massive number. And I think this is the reason why a lot of people really struggle to get their head around this topic, because that number is just incomprehensible to our brains, I think. So if we bring it back down to the idea of eggs, all of a sudden it becomes really simple. So if we want to buy 2 dozen eggs, we have 2 times 12, which is 24 eggs. If we want to buy half dozen eggs, it's half times 12, which is 6 eggs. If we want 3 dozen eggs, we have 3 times 12, which is 36 eggs. Now, when we bring this back to the idea of the mole theory, it works in exactly the same way. So here are a couple of what I call equation triangles. Some of you may have come across these before. Some of you may not have. Some teachers teach this, some don't. I'm a big proponent of this. I'm also a big proponent of using algebra to rearrange equations. But the bottom line is that if the equation triangles work for you, use them. Okay. If you haven't come across equation triangles before, I've got a video on how they work either on my YouTube channel. You probably find it easier if you go to my website at zenofchemistry.com, and it's right on the homepage. So if you don't know how equation triangles work, please just go and check out those videos, and you can actually, all of my formula sheets that have all the formulas for all of Year 11 and Year 12 VCE, you can purchase them at zenofchemistry.com. They have all of the equations that you will use throughout VCE. So if you find that they work for you, these formula sheets are just awesome. So back to our mole theory though. So when I'm talking about 6.02 times 10 to the 23, we're talking about Avogadro's number, which is this Na in our equation triangle. And so it's a really big number, 602 and 21 zeros after it. So if we have 1 mole, so that's 1 mole. Now what is that 1 mole of? It's 1 mole. It could be of atoms, it could be of molecules, it could be of electrons, it could be of lots of different things. But the point is that it's 1 mole of lots of different things. So 1 mole of atoms. Let's go with the atoms, for example. So if we've got 1 mole of atoms, we have 6.02 times 10 to the 23 atoms. So just like our egg example, if we've got 2 moles of atoms, we have 2 times that number. So it's like 12.04 times 10 to the 23, or 1.204 times 10 to the 24. Okay. If we have half a mole of that, you would have 3.01 times 10 to the 23 atoms. So if you think about it that way, that's what this equation triangle is all about. It's about relating mole, which is this N is number of moles, number of moles times by our Avogadro's number gives us our number of particles. So that could be atoms, molecules, electrons, etc. So that's the idea behind moles and Avogadro's number and number of particles. That's that equation triangle there. Come back to our egg scenario though. When we're looking at mole theory and we're thinking about how much does something weigh, okay, I want you to think about, well, you know, I've just been talking about eggs. You know, there are lots of different other types of eggs that are in the world. There's not just chicken eggs, okay, there are, so if we start at the smaller scale, we've got fish eggs. Fish eggs, if you're not quite sure, are usually about 1 millimeter in size. Then we go up to something like quail eggs. Quail eggs are about 3 or 4 centimeters tall. Okay, then we go up to chicken eggs. You know how big chicken eggs are, I hope. Then you go up to duck eggs. Duck eggs are usually about 10 to 12 centimeters tall. And then if you go up really, really large, we've got eggs from whales. And usually whale eggs are around the 30 centimeters tall. So you can see that different types of eggs, because of their different size, are going to weigh different amounts. So if we have 1 dozen eggs, okay, 1 dozen fish eggs is going to have a very small mass. 1 dozen chicken eggs is going to have a much larger mass than the fish eggs. And then the whale eggs, 1 dozen whale eggs is going to be like really heavy. So if you relate the mass of those eggs back to the mole theory, we're actually talking about what's this MR here. So you could relate MR to molar mass, you could relate it to relative atomic mass, relative molecular mass, relative formula mass. There's lots of different names they use basically for the same thing, and that's what I'm going to talk to you about it as molar mass. So molar mass is essentially what is the mass per mole. So if we talk about, you know, eggs, you know, we might say, well, okay, 12 fish eggs weighs 1 gram. So we would say it would be 1 gram per dozen eggs. 12 chicken eggs, I don't know how heavy chicken eggs, but let's say that 12 chicken eggs weighs 500 grams, just to make it a really nice round number. So you would say that that dozen, you have 500 grams per dozen. And then if we go up to our whale eggs, which are, you know, the 30 centimeter efforts, you know, some of those, let's say 12 of that might weigh, I don't know, 12 kilos. So you would say that the molar mass, if you like, or the egg mass, I don't know what you're going to call it, but that mass is 12 kilos per dozen. So it works the same way with molar mass. Molar mass, if we remember that we're talking about a mole, which is 6.02 times 10 to the 23 atoms. If we have a molar mass, we relate this back now to, you know, how heavy are those atoms. So if you look at your periodic table, and this is what's on every periodic table pretty much, lots of different periodic tables have lots of different things on them, but guaranteed or almost guaranteed there's going to be molar mass. So the molar mass of hydrogen is going to be 1 gram per mole, and what that means is 1 gram of hydrogen it contains 6.02 times 10 to the 23 atoms. If we think about carbon, carbon is 12 grams per mole, so it weighs 12 grams for the same number of atoms, just the comparison between our fish eggs and our chicken eggs. If we go down to, I'm trying to think off the top of my head, it's gone, 35.5, chlorine. Chlorine weighs 35.5 grams per mole. So you can see how the mass of 1 mole is going to vary depending on your molar mass. Okay, now I've talked simply about atoms, molar mass of atoms. You can go and then work out the molar mass of molecules or ionic salts. So for example, methane is CH4, 1 carbon, 4 hydrogens. Carbon weighs 12, each hydrogen weighs 1, so your molar mass for methane, CH4, is 16. And so you can do all these sorts of interchangeable equations to work out the mass of methane of 1 mole, or how many moles are in 40 grams of sodium hydroxide, that kind of thing. So it's a case of really bringing that mole theory back to something that is real to you. And that's why I use the egg scenario, is because you can think about a dozen eggs is, 12 eggs. 6.02 times 10 to the 23 atoms is 1 mole. And then if you think about the relationship between 1 mole and its molar mass, which is how big the egg is, okay, you can get to what does it weigh, okay, and vice versa. So what I love about these equation triangles is that you can very easily rearrange your equations to work out moles or mass or number of molecules or whatever it is that you're trying to calculate. So I hope you found this useful. It's this time of year that people start wanting to think about dropping chemistry, and I'm saying don't do that yet. Really sit with the mole theory. It does take time to get your head around it. It does take time to learn how to use the equations. You might get to the point where you have to use 2 of these equations to get to the answer that you're looking for. But really stick with it, because once you've got the mole theory down, pretty much everything else in chemistry starts to fall into place. And when you get to things, calculating concentration, you can very easily just start to apply the knowledge that you learned in mole theory straight into your concentration calculations. Same with gases. If you're doing gas calculations, you pretty much apply the same principles that you were using in your mole theory straight into your gas theory. So I hope you found this useful. If you did find it useful, please give it a like. Please share it with your friends and colleagues. I really want to help as many people with this video as I can. If you really like what I'm doing, please sign up to my mailing list. You can go to zenofchemistry.com and sign up there. Currently I've had a few techie issues, and I'm working through a few different platforms to see what works for me. But essentially what I do is I release a lot of my material for free for short periods of time. So if you'd like to get in on that, please sign up to my mailing list. Please share this around. Thanks very much for joining me, and if you've got any questions or comments, please leave them underneath or to the side, wherever you're watching this from, and I'll get back to you as soon as possible. Thanks very much.